Hello and good day, learners. I am Kea Sacapaño, and for this lesson, we will be learning about the RSA cryptography. Before continuing to learn about this algorithm in this part of the video, I suggest that you first read the description below about the RSA crypto system, and after doing so, kindly play this video again. So I hope you took the time to read about the RSA crypto system. So in this segment, I will be introducing you to the method of generating a public and private key, along with encrypting and decrypting a message using the RSA crypto system. So let us begin. So let us suppose that we were to base from the alphabet A to Z corresponding to the numbers 1 to 26. So our selected two prime numbers are P, which is equal to 53, and Q, which is equal to 71, where we choose our exponent or E to be equal to 3. Now, to generate our public key or NE, we must first solve for N, which can be done by multiplying our P and Q. So we have N is equal to PQ, which will then be equal to 53, which is P, multiplied by Q, which is 71, which will then be equal to 3,763. Now we have our public key of N as 3,763 and E as 3. So for this example, we have the plain text WEST or West to be turned into a ciphertext. So let us first write down our plain text W, E, S, and T. After this, we will substitute these letters to its corresponding numbers in the table. So for W, we have 23. For E, we have 5. For S, we have 19. And for T, we have 20. So these numbers would then be encrypted as follows. So we have 23 raised to our exponent or E, which is equal to 3, modulo N. Our N is equal to 3,763, so it will be E is equal to 3 modulo 3,763. So to solve for this and generate the encrypted message, we go to this website, www.wolframalpha.com, and type in 23 raised to the power of 3 modulo 3,763. Click enter, which is supposed to be equal to 878. So we do the same for the rest, and when you do, you should come up with these encrypted messages. So for W, we have 878. For E, we have 125. For S, we have 3,096. For T, we have 474, which then gives us the ciphertext of 878, 125, 3,096, 474. So that is how we encrypt a message with a private key using the RSA crypto system. Now, how do we go back to the plain text? So we will need to generate the private key or our N and D to be able to decrypt the encrypted message. So let us suppose that we were again to base from the alphabet A to Z corresponding to the numbers 1 to 26. So our selected two prime numbers are still P, which is equal to 53, and Q as 71, where we choose our exponent or E to be equal to 3. So for our private key, we have N and D, where in our N we already have and have solved for, which is equal to 3,763. Now we need to solve for D. And to do this, we need to follow E sub D congruent to 1 modulo R. So before this, we also must first solve for R. So to solve for R, we have P minus Q multiplied by Q minus 1. So our R is equal to our P, which is 53, so it is 53 minus 1, multiplied by Q, which is 71, so 71 minus 1, which will then be equal to 52 multiplied by 70, which will then be equal to 3,640. So our D is equal to 3 sub D congruent to 1 modulo 3,640. And to solve for this, again, we go to the website or www.wolframalpha.com and type in 3D congruent to 1 modulo 3,640, where we will get 2,427, which will then be our D. So now we have our private key of N and D, N being 3,763 and D being 2,427. We can now decrypt the message starting with 878, which will be raised to 2,427 modulo 3,763. So again, by using www.wolframalpha.com, we will input this and we should then get 23. After that, we substitute 23 to its corresponding letter, which would be W. Now, apply this method to the rest, and after doing so, we should have decrypted the numbers 5, 19, and 20, which substitutes to the remaining letters E, S, and T. And that is how we decrypt a message with a private key using the RSA crypto system.